This is problem number 1 on the practice problems for test number 3. Find formulas for the sequences given below. Part A, an explicit formula for the nth term of the sequence 1, 2/3, 3/5, 4/7, 5/9. So it seems like there are separate patterns happening in the numerators from the denominators. So how about we just focus on the numerators? There's a pretty clear pattern here where we just keep adding 1 upstairs, 2, 3, 4, 5, and then separate pattern downstairs. Looking at these denominators, 3, 5, 7, 9, well, those are some of the odds, so we're just adding 2 down there. So it feels like we've got our pattern. Let's make sure that this 1 isn't, that it follows the pattern. So if I were to continue upstairs, the pattern gives me a 1 up there. Continue downstairs, the previous odd number before 3 is 1, and 1 over 1 is 1, so that works. So then I think it's just a matter of explicitly writing down our formula. So this right here is our first term, 2/3 is our second term, 3/5 is our third term. That's probably enough, but we'll just write out the counters for all 5 of these terms. And our job is to come up with a formula for the nth term. So clearly it's going to be a fraction. Let's see if we can just, again, distill the numerators from the denominators. So looking at the numerators, I see here that the 5th numerator is a 5. The 4th numerator is a 4. The 3rd numerator is a 3. The nth numerator is going to be an n. And then downstairs a little bit more work, but let's do it. So downstairs, the 5th term gives me a 9. The 4th term is a 7. The 3rd term is a 5. Our job is to come up with a way to write down a formula for the denominators here as a function of n. N is the counter. So in order to get an odd number, you take an even number and add or subtract 1. So let's see, I guess if we wanted to go from 3 to 5, we could double the 3 and then subtract 1. Let's see if that works here. If we double the 4, we get 8, subtract 1 is 7, double 5, subtract 1 is 9. So I think we've got a way to write this down now. Double the counter and then subtract 1. Part B, a recursive formula for the nth term of the sequence. 1, 2, 5, 14, 41, 122. So recursive just means that we're going to be looking for a rule that tells you how to get to a certain term once you know the previous term, which is different from the explicit formula we wrote up here. If you want to find the 100th term, you just plug 100 into that formula for the ends and you'll get it. That's not what we're after here. So let's see if we can relate any term to the next one. Okay, in order to go from 1 to 2, I add 1. In order to go from 2 to 5, it is unfortunately not add 1, so adding 1 is not the pattern. Let's see, I could double the 1 and get a 2. If I double it 2, I get 4. That's not 5, that's not what I want. So there must be some other pattern here, not just +1 or ×2, but something maybe a little bit more involved. Looking at some more of these numbers here, we see they're getting big pretty quick. So it doesn't seem like we're going to be adding anything consistent. Let's see if we can figure out how to get, say, from 5 to 14, or from 14 to 41. So if you triple 5, that gives you 15, which is 1 more than 14. If you triple 14, that gives you 42, which is 1 more than 41. So I'm feeling like we might have our pattern. The pattern is, in English, triple the previous number and then subtract 1. Okay, so let's see if that pattern works. Your job is to just check. If you triple 1, you get 3, subtract 1 is 2, that's good. Triple 2, you get 6, subtract 1, you get 5. Go down to the 41, triple that, and what do we get? 123, and subtract 1, and we get 122. So I feel like our pattern is good. Now it's just a matter of writing it up. And really it's just about translating. It says take the previous number, you triple it. So 3 times the previous, I'll leave a blank there, and then subtract 1. So the only thing we need to do is put in the blank the generic name for the previous number. Well, if you are sitting on the nth item, then the previous one is the n minus first. So that pattern right there is our recursive relationship. Technically, we should also be explicit and say that the first term is whatever it is. In this case, the first term is a 1. Okay, the blue equation is not the only way. You could also say that an plus 1 is going to be your generic next term to find. Triple, in this case, a sub n would be the current term, and then subtract 1.